Here is another beautiful question shared by one of our subscriber, IBHL Math exam practice. This question is based on vectors. Given two planes, pi 1, 2x minus 2y plus x, z equals to 1, and pi 2 is x minus 2z minus 2 equals to 0. Show that the planes are perpendicular. Find the equation of plane pi 3 perpendicular to given planes and passing through the point 102. I am Anil Kumar, and in this video we'll walk you through all the steps required to understand the concept and solve similar questions. Let's do it. So once we are given the planes from the equation which is in Cartesian form, we can directly get the normal, right? So for the plane pi 1, which is given to us as 2x minus 2y plus z equals to 1, we know that the normal one is basically equal to the coefficients of x, y, z, which are 2, minus 2, and 1, right? Similarly, for the second plane, which is x minus 2z minus 2 equals to 0, normal for the second plane is the coefficients 1, 0, right? This is minus 2 for z. Now, if the two planes are parallel, that means their dot product is 0, right? So the dot product of n1 and n2 should be equal to 0. So that gives you, or rather verifies, whether the planes are perpendicular or not. So we'll do 2 minus 2, 1. So in different parts of the world, this dot product is done in different ways. You follow your own method, simple, and how we'll get the same result. So in dot product, as you know, when you multiply the I components with the I components along the same axis, since the angle is 0 and cos of 0 is 1, we get the value. But if it is I times j or I times k, the angle is 90 degrees and cos 90 will be 0. So the result is definitely multiply the corresponding ijk values, right? So 2 times 1 is 2, minus 2 times 0 is plus 0, I can write, and 1 times minus 2 is minus 2. As you can see, dot product indeed is 0. Now, since the dot product is 0, we say that the planes pi 1 is perpendicular to the plane pi 2. Makes sense, right? So these are all the steps which you need to go through to get to the result. Perfect. Now, the second part is find the equation of plane pi 3. Let's move on to a fresh page. Now we'll find the equation of plane pi 3 perpendicular to the given planes, right? So perpendicular means cross product. So once you do cross product, you get another direction which is perpendicular to both, right? So let's find what is n1 cross n2. So basically what you're going to do is n1 we know is 2 minus 2, 1, and we do cross product with 1, 0, minus 2. Again, everybody is doing cross product in different ways. I will do it using the matrix. So if it is new for you, it is a good opportunity for students to learn how do we use matrix for cross product, right? So what we do is we just write ijk on top. So these are the unit vectors. You know cross product will be a vector perpendicular to the given vectors. Write down their coefficients, which in this case are 2, minus 2, 1, and the other one is 1, 0, minus 2, right? To calculate the value of this, so these are the coefficients of our matrix. So we call this as augmented matrix, right? And the concept of multiplying and working with it is what we are going to use here. I'm not really explaining you the process. Okay. But see how it is used, right? So ijk gets multiplied. So we get this equals to I times. So this part we're looking at, which is this part, I times this. So what we do is we just multiply these things. So minus 2 times minus 2 is 4, minus of this, which is 0 in this case, right? So that becomes the coefficient for I. And for j, alternately we put negative signs. And now for j, what we are going to do is we are going to use these four. So exclude the one which is in the same row and column, right? So the remaining, that forms a determinant. And 2 times 2, 2 times minus 2 in this case is minus 4, minus 1 times 1, right? And then alternately, as I said, plus and minus. For k, we are left with 2 times 0, which is 0, minus of minus 2, which makes it plus 2. So that's what we get. 4 minus 0 is 4, so we can write 4i. Minus minus becomes plus 5j. Unit vectors are written with a cap. And then we have plus 2k. So see, that becomes the normal vector for the given thing, right? So 4, 5, 2 becomes the normal for this plane which is perpendicular. Makes sense? So 4, 5, 2. So the equation basically is, for pi 3, the equation basically is equal to, we can say 4x plus 5y plus 2k, right? We can write equals to something d. To find the value of d, I'm going to substitute the point 102. Make sense? And that gives you the equation of a plane which is perpendicular to this. So I hope this concept is absolutely clear. So finding solution is not a big deal. You also have your marking scheme to go through, right? However, you find my solution slightly different. Since I teach many students in Europe, I know that sometimes the variation and alternate solutions make huge difference, right? So here we are. We have the equation of the plane now, which is of the form 4x plus 5y, since that is the normal, right? Plus 2z equals to d. That means how far it is from the origin, right? Okay, great. Now we'll plug in the point 102 to find the value of d. So it gives you what? So 2 times 1 plus 5 times 0 plus 2 times 2 is the value of d, which is 4 plus 0 plus 4, which is d. And that gives you 8 as the value of d. And therefore, we have the equation of the plane, which is 4x plus 5y plus 2z equals to 8. Makes sense. So these are all the steps required for getting full marks, journey to A+. So that's kind of important. Follow our playlist, understand better, and perform the best. Thank you and all the best. Follow my book and bring alive the real experiences. Thank you and all the best.